In this video, we're going to continue to try to use equations, linear equations, to represent real-life situations. If we think back again to our general linear equation form, y equals mx plus b, m represented the slope. And when we're thinking about a real-world situation, the slope is a description of the rate of change of how our variables are changing, how y is changing when x changes. B, or our y-intercept value, or vertical intercept, is a way that we can talk about the starting value, because the y-intercept is when x is equal to 0. So it's kind of our starting value of where everything works. And if we know a rate of change and a starting value, it's pretty simple. We just plug those numbers into the equation form and we're ready to go. Let's take a look here at question 3. Question 3 says a candy cane company has a machine that produces candy canes. After 3 minutes, the machine has produced 12 candy canes. After 5 minutes, the machine has produced 20 candy canes. Now, in this particular instance, if we identify our variables, our input, and I like to often use x here, could represent the number of minutes that the machine has running. Again, the input is almost always time. So in this case, all of our time values are being measured in minutes. Our output, and I will either use f of x or y, depending on how you want to think of that, would be what we're measuring, and in this case we're measuring the number of candy canes produced. So if we look at our particular problem here, notice that we are not given a rate of change this time. We do not know how many candy canes per minute this machine makes, and we don't know what the starting amount of candy canes at time 0 is. Now, you can do a little bit of reasoning here, but a really good strategy if you get stuck is when you come into a problem like this is to identify a couple of points. What we need for our general equation form is we need the slope and the y-intercept, and we can always find the slope if we know 2 points. Well, in this case, we actually do know two situations. We know that after 3 minutes, the machine makes 12 candy canes. So we can plug in an x value of 3 for our input, and we get a y value of 12 for our output. 3 minutes, 12 candy canes. Similarly, after 5 minutes, the machine has produced 20 candy canes. So we can think of 520 as a second ordered pair point. Now, if you have 2 points, x1, y1, x2, y2, we can actually calculate the slope, and that will be important for us to be able to write our function in function notation, because for the formula, we need both the slope and the y-intercept. So let's calculate the slope found between these 2 points. y2 minus y1, so 20 minus 12, over x2 minus x1, which is 5 minus 3. That gives us 8 over 2, or 4, and from a practical perspective, this slope means that my machine is making 4 candy canes per minute. So if we write this in our equation, y equals 4x plus b, now we can solve for our y-intercept, which we weren't explicitly given. Pick one of our values for x and y. I'll use 3 and 12. So 12 is equal to 4 times 3 plus b. So we're just plugging our point in for x and y here. And when we solve that, 4 times 3 is 12. And then we can solve for b, and we get b equals 0. And that's not really a big surprise if you think about it. When I turn my machine on, I have not made any candy canes yet. So that actually makes sense here in this situation. So I have a b of 0. I have a slope of 4. And that should be enough now to write my function. It wants our function in function notation, so let's just go ahead and write f of x instead of y is equal to the slope 4 times x plus our y-intercept, which is 0. Again, adding 0 doesn't change much in the problem, so you can leave that part out, and we could just say that our function is f of x equals 4x. All right, now once you have an equation, now we can continue then to answer problems about our situation by using the function that we came up with, by using our function model. The next question asks how many candy canes will the machine produce after 1 hour. If we look at our input, x is number of minutes, so we'll have to make sure that we plug 60 minutes in to our formula. So f of 60 equals 4 times 60 is going to give us 240 candy canes after an hour. And then our last example here, how long will the machine have to run to produce an order of 1,500 candy canes? Here we're looking for how long, which means x. That's our number of minutes or time. This is 1,500 candy canes. Here is our, there we go, is our output. So we're going to put this 1,500 is going to be equal to 4x, and we need to solve for x. Just divide by 4 in each case. And in this case, 4 is going to go in there. Let's see, 4 goes in 12, 7, and 5. So 375 equals x, which means it'll have to run for 375 minutes in order to produce the 1,500 candy canes. If you want to know how many hours that is, because that's a better way to report your answer, you can just divide that by 60. So 6.25 hours is how long you'd have to run the machine. And again, if they don't specify, either one of those answers is perfectly acceptable. But sometimes it's nice to have that idea in hours so that you can picture how long you'd have to have the factory up and running to get the order filled.